4 billion years ago, the Earth was in a stage of active development. Newly formed, thin basement comprised by granulite rock complexes was divided into separate segments. Mobile zones confined by deep faults occurred along boundaries of these segments. Intense volcanic activity occurred within the mobile zones. The greenstone belts have been forming during 800 million years. Thousands of volcanoes erupted enormous amount of lava and ash. Eruptive material filled up throws and covered wide areas of land. Today the greenstone belts, these unique structures of the Earth, are a source of numerous types of mineral commodities. One of the main mineral of greenstone structures is gold.
Этот фильм посвящен одной из наиболее изученных зеркальных структур украинского щита. И очень любопытно было бы знать, почему мы начинаем с этого фильма.
This movie is devoted to the thoroughly investigated greenstone structure of the Ukrainian Shield. I'd like to explain why we start series of popular scientific films from this topic, why the Soroky greenstone structure became an issue of our investigations. It's vital to understand that the Soroky greenstone belt is combined tectonic structure. 15 years, different scientists considered the Soroky structure as tectonic zone, monocline or asymmetric greenstone belt. At present, on the basis of ground studies of the Kiev Geologium state mining enterprise, it's evident that the Soroky structure is a clear symmetrical greenstone belt. Features of the structure are similar to greenstone belts of the Middle Dnieper domain. Thus, affiliation of the Soroky structure with greenstone belts is incontestable.
Достижением, значимость которого до сих пор, возможно, не в полной мере осмысленно, является то, что в процессе изучения родопроявлений.
Recent great achievement of our team of scientists is a critical basis of prognosis and prospecting of new mineral deposit within the limits of the Soroky structure. Recently obtained data increase possibility of new gold deposits discovered in this region and in other greenstone structures.
Перспективы как создания минерально-сырьевой базы золота в этом регионе, так и возможности использования этой критериальной основы для прогноза и поисков подобных объектов в других зернокаменных структурах.
The Soroky structure is situated in the western part of the Peri-Azovian domain and strikes over 45 kilometers northwest from the Azov Sea littoral. The Soroky belt is narrow, 2.5 kilometer wide linear through structure. The structure comprises of greenstone rocks of the Olginska, Krutobalkinska and Surorska suits that are members of the Osipenkovska group, Middle Archean. Rocks of the Soroky structure are zonally metamorphosed. Metamorphic grade varies from greenchists up to amphibolite facies. Evidences of the greenstone nature of the Soroky structure are unique composition of rock associations, generalized succession of the rock associations, presence of layered metacomatite flows, presence of pillow lavas in metabasalts of the Olginska suit on the left bank of the Berdanska reservoir.
В этом шурфе, который находится на левом берегу водохранилища Бердянского, вскрывается...
This prospecting shaft of the left bank of the Berdanska Reservoir exposes metabasalts of the Olginska Suit. The basalts are cut by felsic veins of the Shevchenkovsky complex and by numerous quartz veins. Rocks are silicified and altered into skarns. Copper prospect was discovered in this area in 50s. Later, samples for gold is seen were collected. Gold content in the samples was up to 1.5 grams per ton. Metamorphosed volcanic and volcano-sedimentary rocks of the Olginska Suit belong to Metacomatite-Thalite Rock Association. The Olginska Suit comprises early metabasalts, metacomatite, and late metabasalts paragenic associations. Ferruginous quartzites, schists of various composition, and metatufs are components of schist jaspilite formation of the Olginska Suit. Numerous fault breaks divide the Sorokinska greenstone structure into separate areas. Tectonized rocks of the axis part of the large east-west trading Skifsky fault are exposed on the left bank of the Berdanska Reservoir. Meteoroidesite plagiogranite volcano-plutonic rock association is the most important component of the Sorokinska greenstone structure. Ore-producing rocks of this association belong to the Surorska Suit that comprises of felsic metavolcanic rocks and tunnelite plagiogranite rocks of the Shevchenkovsky complex. Tunnelites of the Osipenkovsky Massif intrude the southwestern part of the Sorokinska greenstone structure. Meteorolites and meteoroidesites of the Sororska Suit occur as lens and layer-shaped bodies within metabasites of Olginska Suit.
Метеоролиты Суровской светы.
Meteorolites of the Surorska Suit. It's a very important component of host rock association of the Surors deposit. The meteorolites of the rhyolite plagiogranite association are considered as heat and fluid source of the Surosh gold ores.
правом борту Бердянского водохранилища
Granodiorites of the Osipenkovsky Massif are exposed on the right bank of the Berdiansky Reservoir, near the contact with the volcanites of the Olginska Shield. The granodiorites are weathered and schistose due to their occurrence near the Skifsky Fault.
Левый борт Бердянского водохранилища, мыс Голубые скалы.
This is the left bank of the Berdiansky Reservoir, Cape of Golubye Skaly.
В зоне разлома
There are quartz porphyry dikes in fault zone, on the contact of tremolitites and actinolitites. It is thought that these dikes belong to ore-producing rhyolite plagiogranite association.
в пределах Сорокинской структуры.
The Soroky gold deposit occurs in the central part of the Sorokinskaya greenstone structure near the Berdiansky Reservoir. Host rock strike is changed from northwestern to sublatitudinal within the deposit area. Gold mineralization occurs in the southern limb of the structure that is complicated by anticline fault. Metavolcanic rocks and metamorphosed volcanosedimentary rocks have maximal thickness here. The deposit is situated within the limits of complicated structure formed by intersection of three large faults: Skifsky, sublatitudinal trading, Stepney, northwestern trading, and Sikushi, northeastern trading.
С этого обнажения начиналось изучение Сурожского месторождения. Здесь на дневную поверхность
Study of the Soroky deposit began from this outcrop. Ferruginous quartzites, host rocks of gold mineralization, are exposed here. Geochemical sign of gold and then native gold was discovered by Georgy Lvovich Kravchenko, research scientist of the Institute of Geochemistry and Mineralogy of Ore Formation. Main ore body of the deposit is confined to this layer of ferruginous quartzites. This deposit is only one gold deposit in Ukraine that we can study on the surface. Upper to the slope, the deposit was studied by surface excavation. In addition to the main ore body, drill holes cut number of echelon-like ore bodies in the ferruginous quartzites on deep horizons.
тел, приуроченных в основном к этим же желеистым кварцитам, которые вскрыты скважинами на глубине.
Ore hosting rock complex in the northern part of the Soroky area is overlapped by metabolite rocks of the Kruto-Balkanska Shield. This is the left bank of the Sobachya Gully, its mouth part. Rocks of the Kruto-Balkanska Shield are exposed here. The rocks comprise metasan stones with layers of gravelites and high alumina schists.
Перед нами в этом обнажении один из фрагментов Круто-Балкинской свиты. Здесь мы наблюдаем.
There is one of the fragments of the Kruto-Balkinska Shield in this outcrop. The anacretic minerals of schists are staurolite, cordierite, selimanite, biotite, in places garnet. The schists are sleepy dipping. There are late quartz veins in schists. Early forming quartz veins are usually body-aged, and in cross-section these quartz veins looks like pseudo-conglomerates and pseudo-gravelates.
Псевдогравелиты. Так выглядят некогда целые ранее кварцевые жилы.
Сланцо-Крутобалкинской свиты часто пересекаются.
Schists of the Krutobalkinskaya suit are cut by quartz veins. The veins have various thickness, cut rocks both along rock strike and at angle to rock bedding.
Здесь вверх по балке продолжается разрез Крутобалкинской свиты. В этом береговом обрывчике мы видим фрагмент высокоглиноземных.
Rock complexes of the Krutobalkinskaya suit lengthen up to the gully. In this riverside, we see a fragment of high alumina schists. On the upper part of the outcrop, the schists are disintegrated. On the lower part of the outcrop, the granite-bearing alumina schists are exposed. Rare mineral dolosite occurs here as intergrowth with quartz. On the contact with quartz, veins and dolosite is recrystallized, got regular crystallographic shape, and occurs as excellent mineralogical samples.
Выглядят очень свеже, эстетично, прекрасные минералогические образцы.
Thickness of the body-aged quartz veins that cut the rocks of the Krutobalkinskaya suit is several meters. Metabasic rock sequence that hosts gold ore bodies is 600 meters thick. The rocks are slippy dipping, angles 80-85 grades, and have sub-latitudinal strike. In 60s of the last century, prospecting works for antaphyllite asbestos were carried out within the limits of the Soroky area. Ultra-basic rocks, mainly tremolitites and serpentine chloride tremolitite rock after metacomathites, were exposed by two edits. One of the edits cut the layer of ferruginous quartzite and schists. Caldecine of these rocks has not been fulfilled. This is the right bank of the Burtichia river. In the past, a small farm situated on the left bank of the river. Old-timers said that the owner of this farm, Old Man Soroka, has a luterated cult here. Later, when geologists came here, the vanished farm gave name for the Sorokinskaya greenstone structure. In 90s, the same name gold prospect in ferruginous quartzite was discovered here.
Мы находимся в безымянной балке с правого борта речки Буртичия, которая
We are
пересекает
безымянная gully now.
структуру.
The gully occurs on the right bank of the Burtichia river that cuts the Sorokinskaya structure. Ferruginous quartzites are exposed here. Their handsome rock in all ancient shells of the earth are related to giant iron deposits. In our case, ferruginous quartzites host gold mineralization. Surface samples were collected here. Drill holes were drilled, and in this place the Sorokinskaya gold prospect was discovered.
Выявлено одноименное сорокинское рудопроявление золота.
Remarkable part of the Sorokinskaya prospect rock complexes are high alumina schists. The schists are recrystallized on the contact with pegmatites. A small body of rare metal pegmatites belongs to the Sorokinskoye pegmatite field.
Мы находимся у слияния рек Берестовая и Берда. На заднем дальнем
We are on junction of the Berestovaya and Berda rivers. On the backstage, we can see outcrops of migmatites of the Ramovsky complex. Behind me you can see granitoids of the Saltychansky complex. In this core on the right bank of the Berestovaya river, near its junction with the Berda river, we observe tectonic contact of granitoids of the Saltychansky complex with rocks of the Berestovetskaya greenstone structure. We suppose that the Berestovetskaya structure is a typical greenstone belt of the western Pereazovian domain. Rock associations and morphology of the structure are analogical to the thoroughly studied Sorokinskaya greenstone structure 6 kilometers to the southwest.
Сорокинской зеленокаменной структуре, которая находится здесь в 6 километрах на юго-запад и которая очень хорошо изучена геологами.
«100 метров от контакта с гранитами Салтычанского комплекса».
100 meters from the contact with granites of the Saltychansky complex. Metabasalts of the Berestovetskaya structure have lens-banded structure due to granitization and tectonism. Thick outcrops of metabasalts of the Berestovetskaya structure occur in the riverside along the right bank of the Berestovaya river. The observed thickness of the metabasalt sequence reaches 1 kilometer. Up to 300 meters of granitized metabasalts are exposed in the southwestern end of the Novosoldatskaya village, on the left bank of the Berda river. We are on the southern end of the Novosoldatskaya village. Here on the left bank of the Berda river, interesting granites with black quartz are exposed. Such granites are unknown at least, within the limits of the western part of the Peri-Azovian domain. Today we collected samples for granites absolute age determination.
Графитовые сланцы. Не совсем характерное образование.
These are graphite schists, quite unusual rocks for greenstone structures. On the Berestovetskaya structure, the granite schists occur at 5 meters thick and 10-20 meters long lenses. Stratified components of the basement of the western Peri-Azovian domain are Archean rocks of the Kainkulatskaya and Dragunskaya sequences, as well as Timrutskaya suite. Gneisses, crystalline schists of various composition, and amphibolites are strongly magmatized and occur as complicated faults. Migmatites belong to the Ramovsky plutonic-metamorphic rock complex. Noticeable rocks of the frame of the Sorokinskaya structure are feldspar quartz rocks on the Timrutskaya suite that occur as 100-150 thick lens-shaped bodies. Proterozoic lacocratic granites of the Saltychansky complex intrude both the basement and rocks of the Sorokynskaya and Berestowetskaya greenstone structures. Scenic outcrops of these granites occur in the right bank of the Perda River near the Radionovka village. Rare metal pegmatites are related to the Saltychansky granites, and from several areas in the western part of the Peri-Azovian domain. One of the largest pegmatite felt is Yeliseyevskaya. Mining of the pegmatites for ceramic and radio engineering industry carried out in 60s, 70s of last century. Paleoproterozoic granodiorites of the Abitoshninsky complex are exposed in the northeastern border of the Sorokynskaya structure.
Правый борт реки Камышеватой, северо-восточное замыкание.
This is the right bank of the Kamshevata River, northeastern closure of the Sorokynskaya structure. Exposed granodiorites of the Abitoshninsky complex are cut by complicated veins of lacocratic granites of the Saltychansky complex.
Сложный интрузивный контакт гранодиоритов.
Complicated intrusive contact of granodiorites of the Abitoshninsky complex and migmatites of the Dragunskaya suite. Studies of complex geological structures requires application of modern analytical equipment. New degree laboratory of precise analytical studies enables to determine absolute age of rocks using new high-frequency mass spectrometer with 8 collectors, and to fulfill microprobe studies using scanning electron microscopes of the SUMI corporate enterprise SELMI. Now we are analyzing lead isotope composition directly in zircons. The zircons occur in plagiogranites that intruded the basement of the Sorokynskaya greenstone belt. Measured isotope composition of lead is evidence of zircon age is around 2.8 billion years. Our regular field trip was finished this late autumn. We are returning home, but studies of geology of the Sorokynskaya structure will be continued in laboratories and offices of the Institute. It's long winter wait for us, but we are living our hearts here, dreaming one day to come back to this amazingly beautiful land.
Our